You know, we hear about these massive AI models all the time, but have you ever stopped to think about how they're actually built? Not just the code, but the process that literally shapes their personality. Well, today we're going to pull back the curtain on one of the most advanced models out there to see exactly how it gets so smart. Let's get into it.
And it all kicks off with this really interesting puzzle. Picture this. You've got two AIs. They're built from the exact same digital brain, the same core knowledge. And yet, one of them acts like this raw, unfiltered genius, while the other is a polished, super helpful assistant. How is that even possible?
So on one hand, you have the Qwen3 base model. The best way to think about it is like a massive library of facts. A brilliant mind that knows just about everything, but hasn't really been taught how to chat. And on the other hand, you have Qwen3 Instruct, a conversational expert ready to help you out. They start out as twins, but their education, well, that sends them down two completely different paths.
To solve this mystery, we've got to go right back to the beginning, their shared origin story. Both of these powerful minds were built on an absolutely mind-boggling foundation of data. Just look at this number for a second, 36 trillion. That's the number of text tokens, you can think of them as little pieces of words, that this AI consumed to build its first picture of the world. This giant library is their shared knowledge, the wellspring of that raw genius.
So how in the world do you build a library that big? It's not just about scraping the web. And this is where it gets kind of meta. They actually used AI to help build a better AI. They had a vision model that could read PDFs, another AI that cleaned up all the messy text, and even other specialized AIs that generated brand new examples for tricky subjects like math. It's like the AI is literally teaching its own successor. Pretty wild.
And they don't just dump all this data in at once. No, that would be chaos. It's a very structured curriculum, kind of like school. First, the model gets a massive foundation of general knowledge from over 30 trillion tokens. Then it moves on to an intense second phase, focusing on 5 trillion tokens of specialized data to learn how to reason. And finally, it learns to understand really long documents. This three-step process is what forges the powerful Qwen3 base model.
Okay, so we've built our raw genius. Now for the really cool part. How do you turn that giant walking encyclopedia into a helpful assistant you can actually talk to? This is where their paths split. The Instruct model gets sent to a special 4-stage finishing school. Let's see what that looks like. This is the curriculum for that school. This is the roadmap that takes the genius and turns it into a genuine assistant. It's a 4-stage process that starts by teaching the model how to reason, then rewards it for getting better at it, then fuses that skill with a new personality, and finally gives it one last polish. First up, stage 1. This is all about teaching the model the habit of thinking things through. It's shown thousands and thousands of examples, math, code, logic problems, where the answer also includes a long, step-by-step chain of thought. It's basically learning to show its work, a skill that was just hiding under the surface in that original base model. Next, you don't want the model to just copy good reasoning. You want it to come up with better reasoning on its own. That's where reinforcement learning, or RL, comes in. The model essentially gets rewarded for being more accurate and correct, which pushes it to get better and better at solving really complex problems. Okay, pay close attention, because this next stage, this is the secret sauce. This is the aha moment that really defines the helpful, direct personality of the Instruct model. And it all comes down to a really clever mix of data. In stage 3, they do something brilliant. They fuse two totally different types of data. They keep showing the model those long show-your-work examples from the first stage, but now they mix in a huge number of simple, direct, question and answer pairs. You know, the kind of chat you'd normally have with an assistant. And the results of this mix is fascinating. By seeing both types of examples, the model learns something incredibly subtle. It learns when not to show its work. It still does all that powerful step-by-step thinking in the background to figure out the right answer, but it learns to deliver that answer in a direct, concise way, exactly like a helpful assistant would. And finally, the model goes through one last polishing stage. Using feedback across more than 20 different areas, it's fine-tuned to be helpful, harmless, and conversationally smooth. This is what makes sure it's a reliable and well-behaved assistant for all sorts of general questions. So the crucial point here is this.
The ultimate behavior of an AI isn't some accident. It's not just about its size. It's about the specific data it's fed and when. Data is the architect.
And here it is. This is the evidence that solves our mystery from the beginning. You can see right here, both models share that huge chunk of pre-training data. But after that, the base model's education just stops. The instruct model, though, keeps going, exposed to 4 more stages of highly specialized training. That's the entire difference, a complete fork in the road in their education.
So the thing you should really take away from this is that an AI's personality is no accident. It is meticulously engineered. It's the product of a specific, deliberate curriculum of data designed to shape its behavior, its skills, and even the way it talks to you. And that leaves us with a fascinating question for the future. If data is truly the architect of these powerful minds, it means we can shape them in countless ways. So what kinds of AI personalities, what kinds of specialized digital minds will we choose to build next?